Welcome back. So in previous class we have seen the range equation in terms of transmitter and receiver parameters, so that it was derived as R maximum equal to Vt sigma Ae divided by E4 pi whole square into S minimum whole to the power of 1 by 4. So it implies on what transmitter and receiver parameters the range value can depend. Now let us see the modified range equation in terms of noise. In any communication systems, noise is a major parameter you need to consider. Noise means the unwanted signal which disturbs the original information. Okay, so let's consider the input noise Ni equal to KT naught Bn. Already in analog communication subject, you have gone through how to define and how to express the noise power as KT naught Bn, where K is the Boltzmann constant. Its value is 1.38 into 10 power minus 23 joules per degree Kelvin. T naught is the temperature, again in degree kelvins, and it is considered as 290 degree Kelvin as room temperature. And Bn is receiver noise bandwidth, bandwidth with reference to noise. Okay, so like that, the Ni is, we can express the Ni input power. Okay, next, so in order to estimate the performance of a circuit with reference to noise, usually the metric which is used is noise figure, Fn, where Fn is, we can define it as the ratio of signal to noise ratio at the input to the signal to noise ratio at the output. So the slide showing the ratio of noise figure, that is Si by Ni divided by S0 to N0, where Si is input signal power, Ni is input noise power, S0 is output signal power, and N0 is output noise power. So like that you can take noise figure, so that from this the input signal Si is Ni Fn S0 divided by N0. So it is derived from the noise figure. So just by rearranging the different terms, from this we have taken that Si, that is input signal. Okay, since Ni is KT naught Bn, since the Ni, that is input noise power, we expressed in previous slide as KT naught Bn, so therefore the Si is equal to KT naught Bn Fn into S0 divided by N0. Okay, so now substituting this, okay, before going to substituting, so with reference to S minimum, we can express the above Si as, so by observing that the S value is minimum by maintaining S0 by N0 also minimum, that is the minimum detectable signal. S minimum is the minimum detectable signal, for that S0 by N0 should be minimum. The rest of the terms K, T, B, Fn are all the constants. Okay, so S minimum is where the S0 by N0 of S0 by N0. Okay, so for S minimum, S0 by N0 also minimum. Okay, now in the range equation, if you substitute it, it comes like, so R maximum to the power of 4 equal to Vt sigma Ae divided by 4 pi whole square. So instead of S minimum, now it is expressed as K T naught Bn Fn of S0 by N0 of minimum. Okay, so this is the way how the range equation can be expressed in terms of noise. Okay, is it clear? Okay, so now the range equation in terms of noise we expressed. Okay, it is inversely proportional to the S0 by N0 signal to noise ratio. Okay, then let us see The topic is minimum detectable signal in radar. Minimum detectable signal. So this is the concept including the threshold detection. Threshold detection. Let us see. Here is the A-scope display, like the envelope of the receiver signal. It shows it has different peaks with reference to targets and also with reference to noise. Out of all this, so there are if you observe in the envelope, so many peaks are there. Some of the peaks including the both noise and target, and some peaks represents only because of the noise. Okay. So here simply this peak A, peak B, peak C are the signals with reference to target. Okay, whereas other peaks like this one, and these are the not the peaks with reference to the target. Okay, so now how to extract or how to detect the noise signal, how to detect the target from this, that is by using the threshold detection. Threshold detection is used so in order to know the target. Okay, so that is the signal peak which crossing the threshold level, that indicates the presence of the target. The signal peak which crosses, suppose in this diagram, this is the threshold level maintained. So out of all this envelope, some peaks only crossing the threshold level. So with reference to A, the signal is crossing the threshold level, so that it indicates the presence of the target. Okay. So similarly, with reference to peak of B, also at the threshold level, so that it is also indicates the presence of the target. But with reference to C, the amplitude of the signal unable to cross the threshold level, even though it is also with reference to target, it is unable to cross in the threshold level, so that it does not indicate the presence of the target. Okay, so that is the way how the threshold detection helps to know the presence of the target. Okay, so by observing this, so to to identify the target C also, what you have to do, you need to reduce the threshold level. So if I reduce this threshold level, even the peak with reference to position C also crosses this threshold level, so that is also represents the presence of the target. Okay. Suppose if I decrease further the threshold level, what will happen? The other peaks, maybe these peaks, this is the one peak, this is the other peak, these peaks, actually these are the peaks with reference to noise alone. So that if the threshold level is too low, these noise peaks also can cross the threshold level. Okay, so when the peak crossing the threshold level means, what does it mean? It represents the presence of the target. Okay, but these peaks are because of noise only, not by the target. So that's why there we can get the error results, and these are referred as the false alarms. Okay, so here now what is false alarm is the peak with noise alone which crossing the threshold level and indicating the presence of the target is known as the false alarm. Okay, so the threshold level, so by this analysis what we can know is the threshold level should not too low, at the same time should not too high. If it is too low, what happens? The false alarm indication may be increased. If it is too high, what happens? Even the targets may not be identified by the radar. Okay, So that is the problem of deciding the threshold level. Okay, threshold level. Okay, here but with reference to threshold, so failing to recognize a signal that is present. Suppose if the threshold level is too too high, if the threshold level is too high, failing to recognize a signal that is present. That is present means with reference to target. With reference to target, even though the signal is there, because of its magnitude is less, it is unable to cross in the threshold level because the chosen threshold level is very high. Okay. Suppose if it is very low, what happens? Falsely indicating the presence of a signal when none exists. Okay, that is actually there is no target, but with reference to noise maybe the peaks will be there in the envelope that may cross the threshold voltage level, so that it indicates the presence of target, referred as the false alarms. Okay, so these two happen with reference to based on the choosing of threshold voltage level. Okay, so one is referred as probability of a miss and another one is a probability of the false alarm. Okay, but how to choose this threshold level is, let us observe the probability density functions of noise alone and signal plus noise. So this is a diagram showing two graphs. This is the graph with reference to probability density function of noise alone, and this graph is the probability density of signal plus noise. Signal plus noise. So with reference to this, and this is the vertical line represent the threshold voltage. If the threshold voltage is too low, if I reduce this one, okay, and one more point here is the double hashed area represents the false alarms. The double hashed area represents the false alarm, whereas single hashed area represents the desired targets. Okay. Now, suppose in order to decrease false alarm, that is to decrease this double hashed area, I have to increase the threshold voltage level. So if I increase the threshold voltage level, what happens? The line may be somewhere here. What will happen? The desirable targets also not identified by the target. Okay. Suppose if I decrease in order to know the targets, all the targets, if I decrease the threshold voltage level, what happens? The false alarms, that is double hashed area, will be increased. That means the false alarm is increased. So proper threshold voltage value you need to maintain to avoid the false alarms, at the same time to recognize all the targets. Okay, so this is known as the threshold detection.